Welcome to section 3.4, day 2, derivatives of logarithms. Today's objective is to differentiate logarithmic functions. Yesterday we did exponentials. Today we are going to do logarithmic. Derivatives of logarithms. So we take the derivative of ln of u. So some function is in our ln function, our natural log function. We take 1 over whatever the ln is, so 1 over u, times the derivative of whatever u is over in respect to x. That's a natural log. If we have the log base a of u, we take the derivative, we get 1 over u, natural log of a, times derivative of u with respect to x. So how does this work? So y equals natural log of x cubed. So we want to take the derivative. So we have y prime. Here it says take 1 over whatever's inside. The x cubed is my u. So 1 over x cubed times the derivative of x cubed, which is 3x squared. When you do this and you simplify it, 3x squared over x cubed is just 3 over x. And that is my derivative. When we do the next one, we have y equals log base 6 of 4x to the 4th power. Again, in this case, our u is this 4x to the 4th power. And it says to take 1 over the u, which is 4x to the 4th. We're going to have that times the ln of a, and our a is our base, so ln 6. And then we're going to take that times the derivative of u with respect to x. So the derivative of 4x to the 4th is 16x cubed, using our power rule. When we simplify this, we have 16x cubed over 4x to the 4th, leaving us a 4 on the numerator, 1x left over in the denominator, ln 6. So we get 4 over x, ln 6. You do need to memorize this, just like all the other things we've been doing. So you want to use note cards probably to remember these, but the derivative of ln of u is 1 over u times the derivative of u over with respect to x. And if we have a log base a, we take log base a of u. The derivative of that is 1 over the u times ln of a times the derivative of u with respect to x. So here you have y equals a natural log of sine of x. Again, if you remember, if we take the derivative with respect to x of ln u, it is 1 over u times du dx. So in this case, our u is sine of x. So y prime is 1 over sine of x. And when you do this, you take the derivative of the u. The derivative of sine x is cosine x. This is cosine x over sine of x. And this becomes cotangent x. So our derivative of ln sine of x is cotangent x. Let's do the one on the bottom here on the left. We have y equals 2x ln of x minus x squared. Here we have 2x times ln of x. We have a variable on the outside of ln, and we have an x on the inside of the ln function. We have to use the product rule. So y prime is 2x times the derivative of ln of x, which is just going to be 1 over x, because 1 over u, the x is u, and then the derivative of x is just 1, so 2x times 1 over x times 1, or 2x times 1 over x, plus ln of x, and the derivative of 2x is 2, and then we have this last piece minus x squared. We just use our power rule, minus 2x. So let's make this look a little better. So y prime, we have 2x over x, which is just 2. We're going to bring that coefficient, that 2 up front of ln of x, so we plus 2 ln x minus 2x. And if you really wanted to, you could factor out a 2, but it really doesn't do us anything. So let's just leave it like that. No reason to do the extra work because we can't simplify it if we factor out the 2. On the right side of the slide, we're working with logarithms with bases. So remember this one from the last slide. We have d dx of log some base a of u is 1 over u ln a, and that's times the derivative of u with respect to x. So we're just going to use our formula and plug along. Y prime. Our u is 1 over x squared. So we have 1 over x squared. ln of our base is 9, times the derivative of 1 over x squared. Remember, 1 over x squared is the same as x to the negative second. So this is going to be negative 2x to the negative 3. That's what we're multiplying by. Gonna get a little tight here for room, so I'm gonna move down below the next one so we can have space. We have this x to the negative third. We can rewrite this and put that negative 3, the exponent of negative 3 on the bottom. So I'm going to rewrite this as y prime is negative 2 on the numerator. We have 1 over x squared times x cubed times ln 9. We have x cubed times 1 over x squared, so y prime is negative 2 over x ln 9. This is my derivative for y equals log base 9 of 1 over x squared. The algebra on these can get a little complicated, like this one does. You have to be careful where you put things and how you write them to keep track of these fractions, especially when we have fractions as our u's. All right, let's do the last one. I'm going to erase this to make some room. This one's a little easier, I think. We have y equals log base 8 e to the x. We're going to use our formula on the top. So y prime is 1. Our u is e to the x. Our base is 8, so ln 8 times the derivative of u, and our u again is e to the x. And the derivative of e to the x is just e to the x. Then we are going to simplify this. We have e to the x in the numerator over e to the x ln 8, and we get y prime is 1 over ln 8, because the e to the x's will cancel out. And that is my derivative. This is a big part of what you'll be doing today, using these two new rules. Find the derivative of ln u, and find the derivative of log base a of u. You do need to memorize these. I recommend when you use them, you write them out every time you use them until you have them memorized. I also recommend you use note cards to memorize these. So the last slide for the day, find f prime of x and state the domain of f prime. So here we have f of x equals ln of x plus 3. So this we'll use our natural log rule. So we have f prime of x equals 1 over x plus 3. And then the derivative of x plus 3 is just 1. So our derivative is 1 over x plus 3. And it says to state the domain. Well, in this one, if you look at just the f prime of x is 1 over x plus 3, the one thing we can't have in here is x cannot be negative 3 because we can't divide by 0. But when we're doing these with derivatives, we also need to look at where we start. And we started with ln of x plus 3. With the ln function, we cannot take the ln of 0 or negative numbers. So our x plus 3 has to be greater than 0. So x has to be greater than negative 3. This is my domain. We have to go back to look at both what we started with for our parent function, and then where we're going when we take the derivative. So in this case, the negative 3 is already included in our domain from the ln of x plus 3. So our domain is x greater than negative 3, 0. All right, that is it for section 3.4, day 2. Today we are taking derivatives of the ln, the natural log function, and the log base a function. You do need to memorize these two formulas. I would recommend, again, writing them down every time you use them, using note cards to memorize them. Make sure you're showing your work. Thank you for watching, and have a nice day.